Let's do an example of working with two equations that are coupled through common variables. So our goal will be to solve for the value of the variables that are found in both of the equations. Let's do an example using projectile motion. Here's the setup. Let's say we have a cart here which can launch a ball, and it's moving horizontally at a speed of 1 meter per second. At some time t equals 0, the ball is launched off, like shown, and over the course of some time, the ball travels a horizontal distance of 50 meters, and it travels a vertical distance of 10 meters. The ball is launched at an angle with respect to the horizontal of 45 degrees. Our goal is to find the magnitude of the initial velocity and the time that the ball travels when it goes over this distance here. As usual, we have a couple of different ways that we can approach this to get the correct answer. Let's consider the horizontal and the vertical motion separately, like we normally do with this type of question. So, gravity is acting straight down in this particular case, and since we have some horizontal motion without gravity affecting it, we have our own set of equations that don't involve acceleration horizontally, whereas vertically we have to take into account gravity. So keep in mind here that V0, as is designated here, is actually the velocity of the ball relative to the cart. V0 is velocity relative to cart. Okay? And so we need to keep that in mind because we also have the velocity of the cart relative to the ground. So when we calculate what the velocity of the ball is, we have to add together the x components of this velocity and the velocity of the cart in order for this to work out properly. So let's start off thinking about the x motion. The total displacement in the x direction is equal to 50 meters, as is given. And so that has to be whatever the velocity is of the ball relative to the ground. After all, this 50 meters was measured relative to the ground, so the distance traveled by the ball then is going to be the velocity of the ball in the x direction relative to the cart, which is V0 cosine of 45, plus whatever the velocity is of the cart relative to the ground, which is 1 meter per second. And so velocity times the time traveled then will give us this 50 meters. So that's our equation. And we can simplify that a little bit because we know cosine of 45 is actually root 2 over 2. So root 2 over 2 V0 plus 1 times t equals 50 meters. Now let's do the y direction. So the y displacement in this case is equal to 10 meters. And similarly, we set up an equation of motion, but now we have to think about gravity. So in that case, the equations translate to V0 sine 45, that's the vertical component of the velocity. V0 sine 45 gives you this vertical component of the velocity. Okay, and that's times the time that it travels. Then we have to deal with the acceleration of gravity, and that's acting downward, so it actually acts to slow the vertical velocity. So that would be minus 1/2 10 meters per second squared times time squared. Once again, we can simplify this a little bit by taking out this 45. Sine of 45 is, again, root 2 over 2, so root 2 over 2 V0 t minus 5t squared. Okay, so we can solve this in a couple of different ways. The best thing to do at this point, I think, is to write the two equations out so that they're right next to each other so you can kind of see what's going on a little bit better. So we're going to write down our first equation here, and then right underneath of it, let's put the other equation that we have. Both of these things involve a root 2 over 2 V0 times t, which is going to be suggestive of how we can solve this in the future. All right, so there's our two equations that we want to solve, and the idea will be to take one of them and isolate a variable and then put it into the other equation, or we can add the two equations together in a vertical-like fashion, which is what I'm going to suggest that we do as a way to solve this. Okay, so method 1 may involve solving, say, the first equation here for t, that is, turning this thing into t equals 50 divided by root 2 over 2 v naught plus 1, and then substituting that value of t back into the second equation in order to, you've now removed the t from the equation and it's just in terms of v naught. The problem with this is you're going to end up with t squared here, and t squared here is going to lead to a v squared here, and we're going to end up with this yucky quadratic equation that we don't want to solve. So what I suggest is do not do that approach. That sounds like it'll be just a big hassle to do. Here's a different approach. Let's put this in a somewhat different form that'll make it a little bit easier to see what's going on. Let's write this as 50 is equal to root 2 over 2 v naught times t plus t, and 10 is equal to root 2 over 2 v naught t minus 5t squared. Okay, now we can do the following. Let's say we decide to add these two equations together, but we're going to do it sort of vertically. In fact, what we'll do is subtract them. And in particular, we're going to subtract them because this term and this term are common between the two equations. And sometimes this happens, and it's just falls straight out, and sometimes you have to do a little bit of a manipulation in order to make one of the equations have this happen. In this case, it's pretty simple, so we're going to just subtract this way these terms and get the following. So 50 minus 10 is 40, and then this term minus that term is a big old 0, and then t minus 5t squared is 6t squared. The result then here says that t squared is equal to 40 divided by 6, or t is equal to what looks like 2.58 seconds. With this value, we can now take that into solving for the value of the magnitude of the initial velocity, which is just going to be given by one of our original equations. The easiest thing to do at this point is probably to use this equation here because it doesn't involve a quadratic. And we can turn this thing around and solve for v, and if we do that, we would end up with the following. So this thing here is just the rearrangement of this equation here. We'll take the value of t and put it into this equation and find out that v naught, that's the magnitude of v vector, which we just can write as v naught if we want to like this, is equal to about 26 meters per second. So keep in mind that our two solutions here we could have gotten by doing different techniques. All of these equations can be coupled together to give you the answer in a variety of ways. This method of using this equation subtraction to isolate one of the variables happens to work out much better than trying to do it the other way. It doesn't always work that way. There is another example that I use about a hanging mass that's also posted online, and if you look at that one, you'll find it's probably the same difficulty in either direction, maybe even a little bit easier to do the substitution technique where you solve for one and then put that into the other equation. It's something you have to look at in real time and decide, but keep in mind you can use either one of these techniques successfully.